Well, hello there. Hey, welcome back to Physical Science. We're now going to go to the very last part of Module 4. So far up to this point, just a quick overview. We went over ionic bonds, which was the chemical bond between a metal and a nonmetal. And then we went over covalent bonds, which was between two nonmetals, a bond where you shared electrons. And then the last little part we went over was metallic bonds, which is your keyword sea of electrons type of thing, and that's where you create your alloys from. Now the last section we're going to go over is a very special case, okay? And it gets into a little bit more complex, but it's not that bad. I'm going to show you the easiest way possible to learn it and remember it and know how to play around with it in chemical equations. Okay, so no further ado, let's get cruising. Today's topic is called polyatomic ions. Polyatomic ions. Aha, it already sounds scary, but don't worry about it. Smart people do, and you learned this back in middle school, hopefully, where you learned your STEM words, and that is to break apart the word. Poly. What does the word poly mean? Well, you remember? Most of you are saying it right now. Right. It means many. Okay? It means many. And atomic, well, I think we kind of know something about atoms by now, don't we? Yes, we do. So we're talking about many atoms. But we got the word ion on the end, which means we also know that ion means it's any kind of a particle that has a charge on it, whether it's positive, negative, +1, +2, +5, -5, doesn't make any difference. But as long as it's got a charge on it, it's got an ion. So far up to this point, we've been learning that atoms and elements bond together to create that chemical stability, okay? And that usually afterward, there's really no ionic charge afterward if everything's kind of balanced out. There are some special cases. In covalent bonds, which creates covalent bonds create molecules, there are cases, many cases, where after the elements, the two nonmetals come together and they share electrons, there's still, due to the reaction, how it occurred, there's still an overall charge left over. Not on any individual element, but on the two elements together and the whole molecule itself. On the whole compound, the whole molecule has a charge left over, okay? So that's where it's going to get the word ion from. And the other cool thing we're going to talk about is since we've got covalent bonds, which are nonmetals, so we get this cluster of nonmetals bonded together, and then the overall thing has some sort of positive or negative charge left over. Well, if it's got a positive or negative charge left over, that means we could use an ionic bond to make it bond with a third or fourth or fifth element out there. Okay? So don't worry, it sounds a lot complex, but if it's too complex, I probably wouldn't be able to understand it because I am no chemist by any means. So, polyatomics we're going to go over today is, first of all, you're going to know what a polyatomic is, and now you know what it is. And we're going to talk to you about, or I'm going to talk to you about, how they form ionic bonds, and we're going to write chemical equations. Before you leave this video, you're going to be so impressed. I mean, you're going to stand back afterward, you're going to look at the chemical equation you write and you go, holy smokes. I don't know what's going on there, but man, that's pretty impressive. I know what I'm doing. You're dang straight you know what you're doing. That's right. So, let me show you. What I want you to do right now on your notes is I want you to write down that list right there. Okay? Write down that list. Now that list, thank the Lord, you don't have to memorize it. Okay? You don't have to memorize it. The state on their handy-dandy North Carolina's Department of Public Instruction, on their state reference guide, which got all the formulas for the physics and all this other stuff for chemistry, including the periodic table, on the back. I'll zoom in here for you to see this. Look at that. Right there is this beautiful little chart of polyatomic ions. Okay? Now, I did send you back in module number 1, I sent you the link so that you could download that exact reference sheet. Okay? And if you look at it, there's no parentheses around these polyatomic ions, which you are now supposed to be copying down. Okay? Because we're going to be referring to these, and you'll be able to use them on the quiz. I put parentheses around the outside because I want us to think one thing we're not going to do in here, we're not going to go to a high-level chemistry. Once this polyatomic ion has been made, however made, because we don't really understand it, or we are not going to go over exactly how it's understand. I will attach a video down in the resource section below. And if you want to really get into your chemistry and you really want to know how does a polyatomic ion form, the video will be down there and you can see exactly how they're formed by a teacher who really knows their chemistry. So, on these polyatomic ions, all we're concerned about right now in physical science is that they exist. Somehow or another, they exist. What we're not going to do in here is we're not going to take that polyatomic and split it and make it bond with other things and other places. No. No, 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 no. We're going to take that polyatomic and we're going to keep it inside the parentheses. Do not, under any circumstances, split that polyatomic up. If you want to learn how to do that, you better go take the chemistry class and you can get into some really beefy chemistry after that. What we are going to do is take these polyatomics, we're going to keep them inside the parentheses. We're never going to split them up. Okay, we're never going to split them up. We're going to keep them inside those parentheses, and we're going to treat them like a whole nother separate element. Okay, we don't have to worry about the little numbers in here. Okay, we're not going to worry about the little subscript numbers. We don't care. Okay, we're never going to use them. We're never going to split them up. We're just going to treat that thing like element X. Okay, that's all we're going to know. And of course, they also gave them names. The NH4, when these all come together after the reaction, this whole molecule has a +1 charge. Means it's got one extra proton than it does number of electrons left over. And they call that ammonium. Okay? Unless you can't pronounce that, then you can say ammonium. Okay? And then this one right here, C2H3O2. Some of you are looking at that going, oh my Lord, that's so huge. Don't worry about it. We're not going to mess with anything inside the parentheses. The only thing we're going to do is write this down. We don't have to do anything with the 2, the 3, or the 2. The only thing we need is that -1 out there on the outside of the molecule. Okay? They call that acetate. This one is Cl, not Ci, that's ClO3, chlorate. You know, I was making a big deal about how you make sure that if you got an element that's got 2 letters for it, the first letter has to be capital, the second letter has to be lowercase. This chlorate right here is a primo example of why you must use lower and uppercase. Okay? Because if you didn't, then this could be, Cl is normally chlorine, right? What happens if somebody thought that was an I? Well, then that would be carbon, iodine, and oxygen. What? So, yeah, so that's not a capital I. That is a lowercase l. So we got to be careful about that. This one's nitrate, hydroxide, carbonate, sulfate, phosphate. And notice the ionic charges. That's what's important, okay? And again, you do not have to memorize these. Write those down in your notes so that you've got them right there handy dandy so you can use them. Or if you got your handy dandy state reference guide, you can use that there. But I'll guarantee if you want this to be easy, you're going to write them down just like that with the parentheses. All right, so I'm going to go on. If you don't have those finished written down yet, pause the video, pause the video, pause the video, pause the video, and a little joke there. And then we'll go on from here. All right, now, how to make these things bond and go through their ionic bonds, okay? Now remember, a little keynote here. Just remember metals? Yeah, I remember metals. Metals like to do what with their electrons? Lose. If you lose negative charges, then your metals are going to act like positive ions, right? They're going to be positive ions. Not act like, they're going to be positive ions. And your nonmetals, nonmetals like to gain electrons. So if they gain extra negatives, they're going to wind up being negative ions, okay? Let's keep an eye on that. I want you to remember that because it's that positive and that negative, that opposite attraction, remember that? They come together. That's what created our ionic bonds last time. So we're going to use those negative, and there's one up here with a positive charge. We're going to use those ionic charges on those molecules to behave they're going to behave like metals or they're going to behave like nonmetals, okay? So don't get lost with all the little letters inside the parentheses. Just ignore them, just copy them, no sweat, okay? So here we go, first one. Let's see what happens if we take calcium and we're going to combine it with, let's take something non-intrusive, let's say nitrate, NO3. Now I'm going to use my parentheses, NO3. Now, remember, treat this just like one whole element, just like it was last time, okay? Treat it like it's one whole element. Now, we take these two things, remember, and we put them over here and we put them together. Always list the metal first, or the one that's up front. So we're going to put these together, Ca, use the parentheses, NO3, close the parentheses. Now all we got to do is figure out what the little subscript numbers have to be down here. And we use the exact same thing we did with the oxidation numbers. Remember when we did the ionic bonds? Remember that? So all we need to do is know what is the oxidation number up here for calcium. And you remember, we go to our handy dandy periodic table. In fact, the special one, the modified one, where we wrote the great big 1, 2, 3, 4, 3, 2, 1 at the top. Okay? If you don't have that one, pause the video. Go hunt down that periodic table because you're going to need that. These are the oxidation, remember they're in circles. Oh, oxidation numbers. We're going to need those. So there's calcium right there. You go up to the top of the calcium, top of the column, and you got a 2 up there for an oxidation. So what do we do? Remember, it's been a while, but we put a little 2 up there. Well, what in the world do you put above the NO3? You put down the oxidation number. That's the ionic charge or oxidation number for that one. So that's going to be a little 1 up here. We're not going to be really concerned with the positive or negative right now. If you get to the advanced chemistry, or just take chemistry, then you'll get into the positive negatives a little bit more. But to keep it simple, I'm going to drop the positive negatives. Now, we do the same old thing we did before. Remember? You take your 2 numbers, your oxidation numbers, and whew, you cross them over. Okay? You take this one from up here and cross it down to that one. Take the one from that was up here and cross it down to the one down there. Exact same technique. So this 2 over here on the calcium, where is it going to go? It goes on the outside. Remember, do not touch any of the numbers inside the parentheses. You're not going to play with any of this inside here. Do not change it. Okay? Don't mess with it. Leave it alone. So we're going to copy that 2 and bring it over here on the outside of the parentheses. Okay? Out there on the outside of the parentheses. And the 1 right here is going to cross over. And it's going to go right here after the calcium. And I'm done. That's it. Fine. Gosh, was that hard? Not too bad. Couple more and I think I'll feel comfortable with it, right? So that's really not too bad. So here we got calcium forming with nitrate, which is a polyatomic ion. And then we write the 2 together, just like we did when we did the ionic bonds a week or so ago. And then we do the oxidation numbers, and we cross them over, and bingo, done. Notice, one more time, I'm going to hound you about this so you don't forget. Do not change anything inside that parentheses. You don't have to do anything with this 2 and add or multiply, divide. No. Just copy the 2 on the outside of the parentheses. Okay? That's all you got to do. So let's try another one. Okay? Let's get the hang of this thing. So let's try strontium. Sr. And let's try something a little more beefy, like phosphate. PO4 with a 3- charge on it. That sounds pretty impressive. So here we go. Let's try. Remember, just write it down. Don't change anything inside those parentheses. Just pretend like it's just one element, okay? All right, here we go. Now all we're going to do is when strontium is added to phosphate, it's going to yield or produce. Put these 2 together, right? Right over here. So we're going to put Sr parentheses PO4, close the parentheses. Now we just need to figure out the little subscripts that go down there. Go find the oxidation number. The oxidation number for strontium, it's right there below calcium. So it's in the same column. Go to the top, and there's a 2 in the circle right there. So calcium has got, or excuse me, strontium. I was thinking calcium. Strontium has got a 2. So we're going to put a little 2 up here. And what's the number for phosphate? Well, that's right over here. Phosphate is a 3 minus, or we just need the 3. Okay? I'm just going to use the little 3 right there. And now we're going to play crossover, right? We're going to take this 2, and where's the 2 go? It crosses over. Does it go inside the parentheses? No. Remember, nothing goes inside the parentheses, okay? I'm not going to change nothing. It goes on the outside, way over there. So that 2 goes straight over there, and that 3 crosses over and goes right here after the strontium. And we're done. In fact, if you want to be real slick, you can erase those numbers up there at the top if you want. There we go. What do you think? Not too bad? Feeling comfortable? I hope so. It's really not that bad. It looks, if you stand back and look at it, you go, well, that's pretty impressive. You know, that looks like I kind of know what I'm doing. You know, I got the slightest idea what I just created up there, but I know how to get those things to match up and everything. That's cool. All right, let's try another one. This time we're going to venture into transition metals. Remember when we did those ionic bonds, we had to know how to play with transition metals. So we're going to do that too. So let's try a transition metal. Let's try chromium, Cr. Now remember with chromium, or any of the transition metals, they have to tell you what the oxidation number is going to be. Whether it's 2, 3, 4, 5, whatever it is, 1, they have to tell you what it is. Okay? And remember, there's a couple of different ways they can tell you. They can put parentheses right here and put the Roman numerals there. Or the easiest way, put a little charge number on there, just like you see on the polyatomics. So let's say this is chromium 3. Okay, this is chromium 3. And if you look it up, there'll actually be a little plus sign on there because chromium's a metal and metals like to be positive, right? Because they lose their electrons. So anyways, this is chromium 3. And we're going to combine that with, let's go for carbonate. CO, here we go, CO3, and it's got, well, there's a little 2 sign on there. We can put that up there now, or we can do it later. Some of you are probably just crying to put it on there right now, so I'll go put it on there right now. Okay, you could do it up there if you wanted to also. No harm done. Now, what do? Same thing we have been doing. Just bring these 2 together over here. So here we go. Cr, leave just a tiny little space for the subscript, and there's our CO3, and right there we got to put our little subscripts. So we need our oxidation numbers. The chromium, they already told us, it's 3, so I put a little 3 up there. The carbonate is 2, so I put the little 2 right there. And now you do the crossover. The 3 comes down. Remember, it doesn't mess with anything inside. It has to go on the outside, way over here. Don't worry about that 3. That's fine. We're not going to play with it. Just put that 3 way over on the outside over here. And then that 2 goes where? Right after the chromium. It crosses over and goes right there. Easy. All you got to do is copy down numbers and cross them over. Okay? Not too bad. Not bad at all. Okay? So that's how you do common metals combined with polyatomics. This is how you do a transition metal combined with a polyatomic. And there's a couple other varieties I want to show you. And then I will be done. And you can turn loose and you can practice some of these. For kicks and giggles and for fun, right? Hopefully you're having fun with this. It's not too bad. It's just like playing with some sort of number puzzle thing. Not too bad. All right, next thing we want to do is we want to try, so far we've been playing around and treating these, since these all got negative numbers right here, okay, they've all been behaving like nonmetals. Let's see what happens when we play with this one. This one's got a positive charge, which means ammonium is going to behave like a metal this time. Okay? So let's write that one down first. In this example, we're going to do NH4. Okay? And it's got that little +1 up there. I'll just add that right there. No harm done. And we're going to combine that with, since this is acting like a metal already because it's positive, right? It's a metal, so it acts like a positive. Then we're going to combine it with a non-metal, okay? With a non-metal. So let's try a non-metal here. Let's try nitrogen. Well, we already got nitrogen there. Let's try something different. How about phosphorus? Okay, so we're going to combine this with phosphorus, which is a non-metal. Now, the same thing we did on the other ones. You just bring these two together. This is got the positive charge, so it acts like a metal. Okay, it acts like a metal. So we're going to list that one first. NH4. And leave a little space for the subscript. And then the P for the phosphorus. Leave a little space for a subscript. And now what we're going to do is find the oxidation numbers. Well, NH4 has got what? A +1, right? It's got a +1. So we're going to put a little 1 up here. Right there. And phosphorus, we got to look that one up on our handy dandy modified state reference guide. Periodic table. You find phosphorus is right there under nitrogen. Go up to the top of the column. Remember, we want the number that's in the O for oxidation. Okay, so we're going to put that 3 in there for phosphorus. So we need a little 3 up here for phosphorus. Now all we got to do is cross over just like we did before. So that 1 over here goes, crosses over and goes right there. Okay? And that 3, where's it going to go? It's going to cross over right there. Does the 3 go inside the parentheses? No. Remember, once again, we're not going to mess with anything inside the parentheses. So even though this looks pretty complex, it's actually pretty easy because we're not playing with anything or changing anything inside the parentheses. Okay? Last primo example. What if ammonium acts like a metal and all of these act like nonmetals? So we could take this, act like a metal, and have it combined with one of these to act like a nonmetal. Whoa, that's weird. Okay? Let's try that. Now this is going to look like super complex, like really super smart, but that's so easy. Gosh, you're going to be able to do this. No problem. All right, here we go. NH4. Remember, it's got a little +1 charge. What's the plus charge tell you? It's going to act like a what? Metal, right? It's got a plus charge, so it's going to act like a metal. There's no metals in there, but because it's got a plus charge on it, it's going to behave like a metal, okay? And we're going to combine that with, let's try one we haven't done yet, sulfate. We haven't played around with sulfate yet. We're going to combine that with SO4. Well, maybe you have played with it already. And that's got a little 2- charge on it. There we go. It looks pretty complex. Don't sweat it. Don't sweat it. Don't worry. Don't look at this and go, no. Okay, this is cool. This is easy. Remember, we're not going to play with anything inside here anyways. We're just going to put these two together over here, cross the numbers over, fine. Donnez-vous. All right, so here we go. Copy down NH4. Leave a little space for the parentheses. The other parentheses, right there, we got SO4. Close the parentheses and leave a little space for the other subscript. Now we just need the oxidation numbers, which are right there at the top. So for the NH4, it's a 1. We put a little 1 right there. For the SO4, the sulfate, there's a 2. So put a little 2 up there. Now we do the crossover, just like you did the other ones. Remember, don't mess with anything inside the parentheses. There's nothing to sweat. The 1 comes all the way over here on the outside, over there, and the 2 crosses over right in there. And we are done, my friends. Okay? You now, if you can do this, and you got pretty good idea what's going on, and you're ready to go after that worksheet, you should be proud of yourself because now you know how to write ionic bonds with using polyatomic ions. What? Gosh, that sounded a lot smarter than I am. You now know how to make and write out chemical equations for ionic bonds with polyatomic ions. Whew. That's impressive. You're impressive. If you have any questions, don't hesitate to call me. Well, it might be easier to email me or Zoom. I'm right here to help you. Don't do that worksheet alone. By all means, log into the Zoom and we'll do the worksheet together. Okay, the whole class, when we're here, we all like doing the worksheet together anyways in Zoom. That's what that time during class is normally for. All right, so take care of yourself, take care of your family, and stay safe.